So lesson 6 here involves the focusing on linear functions. So a linear function is any line in the coordinate plane. So let's look down here. So let's pretend this is our coordinate plane. It's any function that we're normally used to seeing that makes a straight line as such. So they have a standard format, or what we call slope-intercept form, which is y equals mx plus b, where m is the slope and b is equal to the y-intercept, or where the graph crosses the y-axis. So for exercise 1, we have to rearrange the following so that they are in slope-intercept form. So we want y by itself in all of these. So to do that, we would have to do minus 2x, and we always want to write the slope or whatever is attached to the x value first. So we would write this as y equals negative 2x plus 8. So that means our slope or rate of change is negative 2. Our y-intercept, or where the graph crosses the y-axis, would be at 8 or the point 0, 8. Let's go ahead and do letter B now. First things first, we subtract our x. Now we have 4y equals negative 3x plus 12. And again, we always want to write the x value first because that's what has the slope attached to it. We then divide by 4. That gets our y by itself. And then we have negative 3/4 x plus 3. So if we looked at this, our slope or rate of change would be negative 3/4, meaning we would do rise over run. So that means we would move down 3 units and to the right 4. And then our y-intercept would be this here, which is the point 0, 3. For letter C, we again are always focused on getting y by itself. So our first step would be to subtract the 5x. And now we have minus 5x plus 20. Our last step would be to divide by negative 10. And that is for this whole side. So now we have y equals 1/2 x. We simplified negative 5 over negative 10. And then minus 2. So our slope would be 1/2. And our y-intercept would be negative 2. So again, we're repeating this process for letters D, E, and F. If you want to pause the video here and give these a shot, I think that would be a great time to do that. But I'm going to continue to go ahead and solve these. So first things first, we need to get y by itself. So I add the x to both sides here. So now I have 3y equals x plus 21. I divide both sides by 3. And now I have y equals, and again, there's an imaginary 1 in front. So 1/3 x plus 7. My slope is 1/3. My y-intercept is equal to 0, 7. Here we have to distribute first before we do anything. So go ahead and distribute. We get 8x minus 4y equals 6x minus 4. So now let's isolate the y. We subtract 8x. Subtract 8x first. So now we have negative 4y equals negative 2x minus 4. We then divide by negative 4. I get y equals 1/2 x plus 1. So my slope is equal to 1/2, and my y-intercept is 0, 1. And the last one here might take a little bit longer. We have to distribute first again. This 2 here. So now we have 4 minus 4y minus 12x equals 24. The next thing I do here is I have to get x by it, or y by itself. So let's go ahead and move over the 4 first. So minus 4, I get 4y minus 12x equals 20. The next thing I'm going to do is add the 12x. I now have 4y equals 12x plus 20. And then I divide by my 4 here. So when I do that, I get y equals 3x plus 5. My slope is 3/1, or just 3. And my y-intercept equals 5, or 0, comma 5. So on this next page here, we have to identify whether or not these functions are linear functions. Meaning, is it just going to be that straight line we talked about, or are we going to have to identify if it's going to be a curved line? So how do we know that? So this one here, this is in our slope-intercept form of y equals mx plus b. This is a linear function. Now, the first step to telling if these are linear functions or not is to get the y by itself. So for this one here, I would subtract my 3x, and we could already tell that there's going to be some sort of x by itself, okay? So I divide by -5. It doesn't really matter what our slope or y-intercept is here. We're just looking to see if this is only x to the first power. So if it's just an x by itself, it is always going to be linear. Now, for letter C here, here's what I'm talking about. There's a squared attached to the x. So that means it would be some sort of curved function. So that is nonlinear. Here we could tell right away if we divide by 1/2 through the whole thing, the x will still only be x to the first power, or just x by itself. So that immediately we can tell is linear. Letter E, we run into that issue of x being squared. This is definitely not a linear function. And then the last one here, if you want to, you could start distributing the 9. You get 9x minus 18y equals 3x minus 16. And if you were to start to isolate y, the x would still be to the first power. There would be no squared or cubed attached to it. So this, in fact, is linear. Now, onto the picture of the graph down here. So now we're going to have to identify these things we were talking about. So the y-intercept of this graph, again, is where the graph or the line function crosses the y-axis. Here is the y-intercept. This would be 0, -1. So it says pick 2 points on the line and find the average rate of change between the 2 points. So remember, the rate of change was f of b minus f of a all over b minus a. The easy way to look at it would be we pick 2 coordinates and we do y2 minus y1 over x2 minus x1. We could also just look at the graph and count boxes between the points. So here's what I mean. So here is a point that crosses a nice spot and a point that crosses a nice spot. This goes up 2, so that is my rise, over 3, my run. So the slope looks like it's going to be 2 over 3. We don't even have to do any calculations here. So let's take a look. Up 2, over 3. Up 2, over 3. It crosses at a nice spot. What I mean by nice spot is, for example, we wouldn't use like this spot here because it doesn't cross at where a coordinate intersects. So the slope of this is 2 over 3. And again, if you really wanted to pick 2 points and plug in, you can. But if you have a picture of the function, you can just count the boxes. And now, for a linear function, the slope is going to be the same for the whole entire line. And then letter C says, now that you have determined the y-intercept and the slope of the line, determine an equation to represent the line shown. So remember, y equals mx plus b is the slope-intercept form where m is the slope and b is the y-intercept. So now that we know the slope and y-intercept, our slope is 2/3, and we always attach the x, and then our y-intercept was -1, so plus b, which ends up being -1. So there's the slope of that